Kia ora. I'm just going to do a walkthrough of page 32 of the Walkermaths calculus book, which is 2.7. Okay, for what values of x are the following functions increasing / decreasing? So they want to know when this function is decreasing. So what we're going to have to do is we're going to find the derivative first, dy by dx. So what we do is we multiply by the power and then reduce the power by 1. And then over here, we'll do the same thing. This one here just disappears. Okay, so now that we've done that, we need to find out where turning points are. And to find turning points, so let's just imagine what's happening. So see how we look for our highest power. Look for our highest power. And if our highest power is negative x squared, so all we care about is its sign. So this one is a negative, and it is a parabola. So because we've got a negative in front of that, and it's to the power 2, it's a negative parabola. So the picture is going to be a sad or negative parabola. It's going to be like this, right? And so this is our function, and our gradient function is therefore going to be a negative linear line. Now, this linear line is going to cross over the x-axis at the point, or at any turning point. So at this one, it's going to cross over at the maximum. So see how we were able to get all of that information just by looking at the highest power and working out that it was a negative parabola. So this here's our derivative, dy by dx, and this one is y. I'll make that as clear as possible. Right? Now what we can do to find out where that turning point is, all we need to do is set that to 0, because 0 is going to find out where this line crosses over, or where the x-intercept is, and that will inform us as to where the maximum is. So I'm just going to set that equal to 0, so 0 equals negative 2x plus 8. And let's do some rearranging. I'm going to pull the 2x over here. 2x equals 8, x equals 4. So we now know that there's a maximum at x equals 4. And that's all the information we need to find out when the function is decreasing. Because now we can look over here, and the function is going to be increasing up until the max, right? It's going to be increasing. Oops. And then after the max is when it's going to be decreasing. So we know that our function is decreasing at every point from this point here, which we found to be x equals 4. Okay, so then all we need to write, we can say the function is decreasing when x, and it's everything to the right, when x is greater than 4. And that's all we need to do. Okay, so I'm going to skip question now. We'll go to question 3. So we want to find out when this function is increasing. So what do we do again? We look here. We look for the highest power. Highest power of x is probably a better way to look at that. And then let's just find out what's happening. Well, so it's to the power of 3. So we know it's a cubic. And it's positive. So the picture is going to be that of a positive cubic. So let's draw that. Now how do we remember what a positive cubic looks like? Pretty much the way I remember is if it's any even power, it's going to be like smileys if it's positive. Right? So it's going to be that, and it's going to be sort of like a smiley of that when it's an even power. But then when it's an odd power, it's going to be things that are increasing in general. So the straight lines will look like that. The cubics will look like that. See how it's increasing mainly. And then, what's the other one going to look like? sort of like this, and it's going to be overall increasing. So these are what all of the positive ones look like. And then all of the negative ones are going to look like the opposites of that. Oopsies. Yeah. Right, so because this one's a positive cubic, see how that's here, it's the one that's overall increasing. So we know that it's a positive cubic, so then we can look here and we can see, well, there's going to be a max and there's going to be a min. Oh, right? And then this is y. So what's dy by dx going to become? Well, we could either just know off by heart that a positive cubic is going to get us to a positive parabola. And the positive parabola is going to be crossing over the x-axis. Boop and boop, where these occur. Right? But we could also see that by just simply doing the derivative here. So let's just do that. dy by dx equals 3x squared multiplied by the power reduced by 1 minus 3. That's what our derivative is going to look like. That disappears. And then we can see here that it's a positive parabola. Right? So just like that, just like we were saying. So now let's do this thing. We'll set our derivative to being 0. And what we're really doing there is you've got this like axis here. So when you set it equal to 0, you're saying at this point here, right? You're saying when it's equal to 0. So then it's going to find us this intercept and that intercept. So let's do that. Set it equal to 0. 3x squared minus 3. How do we solve for this? There's a couple of ways to do it. I think we're going to just rearrange. Both ways look so beautiful. Like factoring out the 3 looks pretty as here, but I also like the idea of throwing 3 over here. 3 equals 3x squared. Then divide both sides by 3. 1 equals x squared. So then x equals plus or minus square root 1. So it's just a positive 1 and negative 1. So actually this line that I drew would be going straight through the middle, with this being x equals negative 1 and this being 1. Right? Okay, so now what are we trying to do again? We're trying to find out when it's increasing. Well, here we can see here is increase. What am I going to say? Just put an I next to it, eh? Right, and then here you're going to have some decrease. I'll put a D next to it. And then here again you're going to have increase. So referring to this picture is going to make these way easier. Okay, so we're trying to find out where it's increasing. So it's increasing before this point and after this point. So how are we going to write this? So it's going to be increasing when it's less than negative 1. So when x is less than negative 1 and after x equals 1. So it's going to be increasing here as well. So it's going to be when x is greater than 1. Now, lots of mathematicians have trouble with these. Don't worry, you're not the only one. Just remember that the crocodile eats the bigger one. So if I want to say x being less than negative 1, I just make sure that the crocodile is going to be eating the negative 1 instead of the x. That means whenever x is less than the negative 1, it's increasing here. Okay, should we do a little skip over to question 5? Okay, when is this function increasing? Okay, same thing. Look at this. This is our highest power, and we can see it's negative, and we can see it's a parabola. Right? So what we know is it's going to be a sad... Oh, who made a mistake? I did. There is... Whoopsies. Whoopsies. Look at that crossing out. Beautiful. Actually, this is our highest power to the power of 3. So this is actually a negative cubic. But don't worry. Can I make this work to be a negative cubic? Not really. Because a positive cubic is overall increasing. That means a negative cubic. So we got like, there's going to be a negative parabolas. And a negative cubic is going to be overall decreasing. So can I make that fit into there? Maybe I can. Let's see. Quite ugly. Oh well. Doesn't Negative cubic. So we can then look and we can see that this is a local min, and we can see that this is a local max. Right? And straight away, before we even draw anything, we can see that here is decrease, here is increase, and then here is decrease again. So there's only one place where it is increasing, and it's between the min and the max. Okay, so let's do the derivative. I'm going to go with y dash this time. Ooh, that's a pretty y. Pretty dash as well, actually. Okay, so what we do is going to be 9 minus 6x minus 3x squared. We then, so it's going to be, it goes from a negative cubic to a negative parabola where these 2 points are the crossover. Let's draw that in. Ooh. I missed. Oh, I missed. Well, and that's going to be when y dash equals 0. It's going to be here, and it's going to give us 2x coordinates. So we'll set that. 0 equals, let's rearrange it, negative 3x squared minus 6x plus 9. Okay, so this one here we're going to factorize because I can see some nice little patterns emerging. I can see this negative, we want to get rid of it, and these are all multiples of 3. So let's divide everything by negative 3. 0 equals x squared plus 2x minus 3. So we need two numbers that multiply to get negative 3 and add to get positive 2. So we could do 3 and negative 1. So 0 equals x plus 3, x minus 1. So that means we get our 2 points are at x equals negative 3 and x equals 1. Which one's going to be on the left? It's going to be the negative because it's lower, right? So it happens here. X equals negative 3 is going to be that point, and then x equals 1 is going to be the other point there. Okay, so where is it increasing? It's increasing between those two numbers. That's where we've got our increase. So y is increasing, and it's this we're going to go fancy. We're going to go when negative 3 is less than x, but also it has to be bound by the fact that x needs to be less than 1. So see how this gets us like a little bound, so that it's increasing from negative 3, and x is in between them, up until 1. So if x is between those two values, that is when it is increasing. Sweet, hope it helps.